Here's another type of problem you'll see in WebAssign for section 6.1 when you're given a logarithmic equation and asked to determine the domain for the function.
Interruption, miss.
Okay, yes, pardon the interruption. I think now I understand why they record these things in a studio sometimes. All right, so determine the domain for each logarithmic function. Key thing to remember is the input to a logarithmic function has to be positive. Okay, which means that the input has to be greater than 0. So I'm going to go ahead and take x plus 5 and set up an inequality. X plus 5 has to be greater than 0. That tells me x is greater than negative 5. WebAssign will expect you to write that in interval notation, so you'll probably do it like this. Notice that I have a parenthesis around the negative 5 because you cannot equal negative 5. You have to be greater than negative 5. Let's take a look at another one. F of x equals the natural log of x squared minus 6x plus 8. I know that some of you panic when you see this. OMG, what does ln mean? Well, that means natural log. But again, same rules apply. The input has to be positive. So we're going to take a look at x squared minus 6x plus 8. Right away, I'm going to factor that into x minus 4 and x minus 2. And I want to make that positive. I'm now going to go ahead and construct a sign chart. And I'm going to put the number 4 on my sign chart, which is a 0. 2 on my sign chart, which is a 0. And then I'm going to look at the signs as I come down the number line. Positive here, negative here, positive here. I went through that really quick, but at this point in the year, we ought to be able to construct a sign chart for the product of two binomials like this pretty quickly. Okay, so I have to choose values that give me a result greater than 0. So I'm going to say the following. My domain is from negative infinity up to 2, and then from 4 to infinity. Those are the intervals that give me a positive output. Just want to say one last thing here. Just a second ago I said this is the interval that gives me a positive output. What I meant to say there, they give me a positive output to the expression x squared minus 6x plus 8, which is then input to the natural log function. So those give me a positive input for the natural log function. Okay, let's move down to example 3. F of x equals the log base 10 of the quantity x minus 5 over x squared minus 2. First thing I'm going to do is I'm going to rewrite this thing. And I'm going to say this is really the log of x minus the square root of 2 times x plus the square root of 2, like this. So how did I know that x squared minus 2 factors into x minus root 2 and x plus root 2? Because I've done a few of these problems before, and I know that that can be written as a difference between two squares, and the square root of 2 squared is 2. Okay, at this point, I recall that the input to the log function has to be positive, so I'm going to go ahead and construct a sign chart. I have 3 different values I have to put on this sign chart. I need to put 5, because that makes my numerator 0, and then I need to put root 2 and negative root 2, because those two values make my denominator equal to 0. So those are restricted values. Now, in terms of the sign chart, if I pick in a test value here out at like, for example, x equals 6, this will be positive. As x minus 5 becomes negative, the whole thing turns negative. As x minus root 2 becomes negative, the whole thing swings back to positive. As x plus root 2 becomes negative, we swing back to negative. So what is the domain? The domain of this function would be all x values that give us a positive value on the sign chart. So that's from negative root 2 to root 2, and then from 5 to infinity. Again, notice these are open intervals because we cannot equal 0. We have to be greater than 0. I have two more function example domains I would like to do for you here. The first one is f of x equals the log of the absolute value x plus 4 minus 7. Remember the rule. This has to be greater than 0. So the absolute value of x plus 4, all minus 7, has to be greater than 0. In order to further analyze this expression here, I'm going to take a look at x minus 4 two different ways, the absolute value of x minus 4. If x is greater than negative 4, this thing will just act like x plus 4. If x is less than negative 4, then this thing will act like this, the opposite of x minus 4 minus 7. Okay, so now I have two different inequalities, and the strategy that I just used here was to look at the absolute value of x plus 4 as a piecewise function. And if you're not sure what I did there, you can go back and review that in one of our previous chapters. I'm going to go ahead and pause the video and solve these two different inequalities right now. The inequality on the left has a solution that says x is greater than 3. The inequality on the right has a solution that says x is less than negative 11. If you're interested, we can just kind of draw that on a sign chart quickly. That's something we've been using pretty frequently, so I'd like to continue to do that. Those values will give me zeros for the expression inside the logarithmic function, and I will be positive out here and here, but negative in the middle. So our domain interval will be from negative infinity to negative 11, union with 3 to infinity. Okay, in this last example, it's a little more involved than the other examples we've looked at. We have 1 divided by the quantity 2 minus log base 6 of x. First thing we want to look at is this. X is the input to a logarithm, so x has to be positive. That's one domain restriction we have. The other restriction we have to look at is this denominator. We have to say 2 minus the log base 6 of x cannot be equal to 0. So let's see when it does equal 0. I'll solve this equation by adding log base 6 of x to both sides. That gives me 2 equals log base 6 of x. And now I'm going to rewrite this as an exponential. This equation is equivalent to 6 squared equals x, which means 36 equals x. And remember, this was a domain restriction, so all these are not equal signs. So I now have two different expressions here that I can turn into my domain statement. The domain of this function is from 0 to 36. We remove 36 and then continue towards infinity.